Welcome back, AP Stat. This is the second and final part of Chapter 24. We're going to be talking about confidence intervals for a paired t-test. So, when all the conditions are met, which are the same conditions and assumptions for a paired t-test, all right, so the same as we discussed in the last video, and we'll review that again in this video, but it's the same as in the last video. We're ready to find a confidence interval for the mean of paired differences. So this confidence interval is going to be for the differences between the pairs of data values. Confidence interval is centered at the mean difference of our paired data values, plus or minus a t-star value, a t-star critical value with n-1 degrees of freedom, times a standard error for the sampling distribution of sample mean differences, right? So it's built like any other confidence interval, centered at a point estimate, and we go out a certain number of standard errors, okay? The standard error is this, if we need to apply that, which we may. I'll cross that bridge when we get to it. Critical value t-stars from the t model, n-1 degrees of freedom, hence the n-1. You're used to this at this point. If you see something called a matched pairs t-interval, that's the same as a paired t-interval. That's another way of saying the same thing. So, to the right are data on the ages of 7 British husband and wife pairs. So 14 total people, but 7 pairs. So our sample size in the end is not going to be 14, it's going to be 7. Summary statistics and a histogram for the differences for 170 such British couples are below. Again, the sample size is not going to be 340. It's going to be 170 because there are 170 pairs. Okay? So we have a table over here giving us an example of 7 values. You have the wife's age, the husband's age, and the difference, and it's specifically husband minus wife. All right? And here's the husband minus wife ages. Okay? So we have a sample size of 170, an average difference of 2.2 years considering these data values and all 163 others, and a standard deviation for our sample for the differences of 4.1 years. All right, so we have information about our sample mean for our differences and the standard deviation of our sample of differences. If we were to make a histogram, this is a wonderful histogram. This is a histogram that is begging us to analyze the data. It's begging for us to make a confidence interval. It is very unimodal and remarkably symmetric. All right? So we're going to find the 95% confidence interval for the difference in age between the couple's husband minus wife. So first we need to check off the conditions. The data are in fact paired. They are from members of married couples. All right, we got husbands and wives here, and so the age of the husband we should assume has some influence over the age of the wife, so those are definitely paired data. We have reason to assume independence within each sample. We can check that via randomization. These couples are randomly sampled. 10% condition, it's far less than 10% of all married couples in Britain. Nearly normal condition is more than satisfied. That was a wonderful histogram there. So the conditions are met. We can use student's t model with 169 degrees of freedom. That's 170 minus 1. Remember, our sample consists of 170 pairs, so that minus 1 is 169. And find a paired t interval. All right, so now let's go to the calculator. All right, welcome back to the calculator. We're going to go to stat. We're going to go to tests. And we're going to go down to number 8, t interval. Okay. And we have stats to enter here. We do not have raw data. That's always nice. We have a mean difference of 2.2. We have a standard deviation of our differences in our sample of 4.1. Sample size of 170. And we want to find a 95% confidence interval. We hit calculate. And there is our confidence interval. And you will notice very quickly that interval does not cross 0. That's important. So we found our confidence interval, but I'm going to go a little beyond what the question asked and interpret this interval. Our 95% confidence interval for the mean difference in marrying age for British couples, husband minus wife, is that. And we notice that that interval does not cross 0. And we know that we're also doing husband minus wife. So these values are all positive. That means that on average, husbands are going to be older than their respective wives, all right? So since a 95% confidence interval can be used as a two-sided alternative hypothesis test at alpha equals 0.05 level of significance, we can conclude that on average, the marrying age for husbands is significantly greater than the marrying age for their respective wives. All right, so there you go. So this slide kind of puts a little bow, no pun intended, on the top of the last couple of chapters. So for each of these scenarios, 1 through 4, and 4 has 2 separate cases, that's an especially fun problem, would you use a two-sample T or paired T method, all right, or neither? Why or why not? And we say why not because it's possible that we could be using neither a paired T method like we discussed in this chapter, nor a typical two-sample T method that we talked about in chapter 23 for independent samples, okay? So, also, would you perform a hypothesis test or find a confidence interval? All right, so I'll show you how to do number 1, and I will hand the rest of them off to you, and you can compare your answers with mine. So, for number 1, our textbook says random samples of 50 men and 50 women are asked to imagine buying a birthday present for their best friend. We would want to estimate the difference in how much they are willing to spend. All right, so would we use a two-sample T or paired T method or neither? And would we perform a hypothesis test or find a confidence interval? So, here is my answer. I would use a two-sample T interval, all right? Samples are independent of each other, all right? These are not husbands and wives. These are just 50 men and 50 women. So the samples are independent of each other, and we want to estimate a difference in spending, all right? If we want to just estimate a difference, a confidence interval is most appropriate. If we want to determine whether that difference is significant, a hypothesis test would be more appropriate. All right, so down here you may have noticed, in general, if you want to estimate a difference, you use a confidence interval. Or if you want to show there is a significant difference, we use a hypothesis test. And yes, a two-sided alternative confidence interval can be used in place of a hypothesis test, but in general, if you want to estimate a difference, use a confidence interval. If you want to show that the difference is significant or not, use a hypothesis test, okay? So let's look at number 2. Mothers of twins were surveyed and asked how often in the past month strangers had asked whether the twins were identical. Think about what kind of test would you use. Would you use a two-sample T test, a paired T test, a paired T interval, a two-sample T interval, or something different? Pause the video, come up with an answer, and you can check it against mine. All right, I'll assume we're ready to continue. The book threw us a curveball. We would use neither a two-sample T method or a paired T method. We would want to actually use a one-sample T interval. There's only one sample, and we're estimating the mean number of times mothers are asked this question about their twins, okay? So, we actually would want to use a one-sample T interval because there's only one sample of individuals. Don't let the twins fool you. People are asking mothers, not the twins. All right, so let's look at number 3. Are parents equally strict with boys and girls? In a random sample of families, researchers asked a brother and sister from each family to rate how strict their parents were. All right, so think about whether you would use a two-sample T method, a paired T method, or neither, and would you perform a hypothesis test or find a confidence interval? Pause the video, try this one, and see if you get the answer. Okay, I'll assume we're ready to continue. I would use a paired T test, a hypothesis test. Now, why the paired T method in general? Well, the samples are dependent. We have matched pairs of siblings, all right? A brother and sister from the same family, all right? Since they're brothers and sisters from the same family, they're matched pairs, we should not assume independence. They are dependent, all right? So, we want to determine if there is a significant difference between the strictness toward boys and girls from the perspective of the boys and girls. So we're trying to determine a significant difference. That is when we use a hypothesis test. Now let's look at number 4. 48 overweight subjects are randomly assigned to either aerobic or stretching exercise programs. They are weighed at the beginning and end of each experiment to see how much weight they lost. All right? Let's look at part A. We want to estimate the mean amount of weight lost by those doing aerobic exercise. So, do we want to perform a hypothesis test or find a confidence interval? And would we use a two-sample T method, paired T method, or something else? Give this one a go, pause the video, and unpause when you want to check your answer. Okay, I'll assume we're ready to continue. Here comes the answer. We would want to use a paired T interval. The samples are dependent, and we want to estimate the mean difference between the beginning and end weights. All right? So for each individual, you have a beginning weight and an end weight. Now, we're only talking about aerobic exercise, but don't let that fool you. There's a beginning and an end calculation for each individual participating in this aerobic exercise. All right? It's one sample, but there's before and after values. So we need to use a paired T interval because we're trying to estimate the mean difference, okay? The mean amount of weight lost. So that's a great instance in which we would use a paired T interval. Okay, part B. We want to know which program is more effective at reducing weight. Ooh, more effective, okay? What do we want to do now? Do we want to do a hypothesis test, find a confidence interval? Do we want to use a two-sample T or paired T method? Give it a go. Try this. Pause the video and unpause when you are done. Okay, let's check out the answer. I would use a two-sample T test. The samples should be independent, all right? They are assigned at random, all right? To the two groups, so we can check off randomization. That randomization alone is going to make those two samples independent, all right? So, two-sample T test. We want to do a hypothesis test because we want to determine whether there is a significant difference between the programs. Yeah, it might be nice to know the extent of the difference, but what we're trying to see is the difference significant? And when significance is the question, and we're not just estimating a parameter like a mean difference, it's best to use a hypothesis test. All right? Hope this exercise was helpful to you. I know that it is quite helpful to me. It was quite helpful to me in my understanding when I started teaching AP Stat. This was a great slide for me to reflect on. Hopefully it's the same for you. And hopefully this homework is helpful too.